Hello, let's continue to the lecture 1 of inverse trigonometric function. As we have discussed, sine inverse sin x, cos inverse cos x. Now from this lecture, we'll start from tan inverse tan x, cot inverse cot x and others. So let's take a review of sine inverse sin x. As you know, these are the periodic function. So its period is 2 pi, as the innermost function has a period 2 pi. So sine inverse sin x has period 2 pi. It repeats its behavior after every 2 pi interval, and it splits in 3 definitions. Value x lies between minus 3 pi by 2 to minus pi by 2, that is minus pi minus x. And here what we say, minus pi minus x. When x lies between minus pi by 2 to plus pi by 2, then its value is x. And when x lies between pi by 2 to 3 pi by 2, then the value is pi minus x. This is sine inverse sin x. Similarly, go for cos inverse cos x also. Cos inverse cos x is, this is x if x lies between 0 to pi. So it splits into only 2 definitions. When x lies between 0 to pi means cos inverse cos x. For angle x lies between 0 to pi, mind this point, these all x are in radian. So x lies between 0 to pi, then cos inverse cos x is x. When x lies between pi to 2 pi, then cos inverse cos x is 2 pi minus x. So here there are the 2 cases only. Between 0 to pi interval, cos inverse cos x is x here. Between pi to 2 pi interval, it is 2 pi minus x. And the mountain like structure, inverted V shape structure is there. Cos inverse cos x, you have to mind this point, y equal to x and y equal to 2 pi minus x, and rest other function you have to include 2 pi period plus minus in both sides for each and every results. For example, like this one, we have to reduce this from y equal to x to y equal to 2 pi minus x. If you see here, then this is the line y equal to x here, and this same line here after 2 pi interval, that is y equal to x minus 2 pi. Then after 2 pi here it covers just like 4 pi, and then after once again this result will become y equal to x minus here this is x minus 2 pi, and then after 2 pi interval, now include 2 pi more interval here. So after 2 pi, that is x minus 4 pi here. And if you see this one as like this part, y equal to 2 pi minus x, here that will become 2 pi minus x. So here what is there? Here you have to say for this one, y equal to it intersects at 2 pi, here it intersects at 4 pi, so 4 pi minus x. Similarly this one, y equal to that what we say here, then after 4 pi that is 6 pi, y equal to 6 pi minus x, y equal to 6 pi minus x. But when you see this one, so y equal to minus x, and here you have to include 2 pi. So y equal to minus x minus 2 pi, y equal to minus x minus 2 pi. Then after later on here you will get once again this for this part, that is y equal to minus x minus 4 pi. Here it comes for minus 4 pi, and so on like this. Okay, fine. So this much we have studied. Now from this video let's start tan inverse tan x. So similar pattern, tan inverse tan x is here when x lies between minus pi by 2 to plus pi by 2, that is x. And when x lies between pi by 2 to 3 pi by 2, then the result is x minus pi. So that the tan inverse tan x comes in the principal value. Okay. So here tan inverse tan x is throughout it is increasing function, but despite of sine inverse sin x and cos inverse cos x, as this one is increasing function tan inverse tan x, but if you see here the sine inverse sin x and cos inverse cos x, here it is increasing as well decreasing also. So increasing in the interval minus 3 pi by 2 to minus pi by 2, that is y equal to minus pi minus x, minus equal to minus pi minus x. This result is decreasing over here, and this result is increasing over here, you see here, and then after once again decreasing. So decreasing, increasing and decreasing. So in these 2 cases, if you see here this, let me notify here, this is decreasing, and here only that is the result is increasing. But in the cos inverse cos x, only those 2 different conditions are there. Here one is increasing and other is decreasing. But if you see here tan inverse tan x, then that is the only increasing function. So the result is, as tan period of tan x, if you see here, period of tan x, period is here pi, period of tan x is pi, so tan inverse tan x is also pi. So after every pi, here it repeats its behavior. You see tan inverse tan x here, like this. The graph is, if you see the graph over here, let me zoom in the graph over here. So if you come for this graph, then this is the graph of tan inverse tan x, you can see over here. So let's see, between minus pi by 2 to plus pi by 2, this is the line y equal to x, and after that you have to make a pi interval over here. So y equal to x minus pi, this will become x minus pi, this is x minus pi, this is also x minus 2 pi, because if you extend this, as it is passing through y-axis to x-axis 2 pi, so if you extend this here, then it will intersect on y-axis at minus 2 pi. So here you can say y equal to mx plus c type structure, so y equal to x minus 2 pi. If you extend this line, then here it intersects intercept on y-axis as pi, so y equal to pi plus x. Let me go detail in tan inverse tan x to draw the graph over here. So if you see the graph of tan inverse tan x, let me draw first x-axis and then what we call y-axis. As you know, tan inverse tan x here, let me write tan inverse tan of x. So its period is pi, so you have to mark these all pi points. Let this be pi, this be 2 pi, this be 0. Also it is a multiple of pi, that is minus pi, and here it is minus 2 pi. Fine. Now you have to mark the points where it not defined. Tan x not defined where? At every odd pi by 2. So pi by 2, another odd pi by 2, that is 3 pi by 2, and then after you say 5 pi by 2. Here that is minus pi by 2. Here that is minus 3 pi by 2, and so on. So at pi by 2 and minus pi by 2, it shows whole, means it doesn't define. So here also it doesn't, so you have to make a single hole over here. And from tan inverse tan x, if you see tan x 0 to pi by 2, tan x is positive, right? Increasing also, and tan inverse x is also increasing. So increasing of increasing, increasing of increasing is also increasing. Hence the graph will go like this way. So I will use red color over here to draw the graph of tan inverse tan x. So you join these two lines, and here this is the line, this is y equal to x. Now once again you have to draw the graph like this way, this over here. So if you draw the graph here, then this is another graph, and it lies from minus pi, this one pi by 2 to 3 pi by 2, pi by 2 to 3 pi by 2. At pi by 2 and 3 pi by 2, this is 3 pi by 2. So the 5 pi by 2 over here, right? So pi by 2 and 3 pi by 2, there will be a hole. It's not a part of the graph. So at pi it's just 0, and it's increasing over here. So at pi by 2, the result is here minus pi by 2, and here at 3 pi by 2, it approaches up to pi by 2 over here on y-axis, pi by 2, and this is minus pi by 2, you can write over here. So here what the result will be, as this line is y equal to x, so this line what it will be, you can guess over here. So if we extend this line, then it intercepts, make the intercepts on y-axis as minus pi. So y equal to, that is minus pi plus x, right? Minus pi plus x, as intercept is 45 degree, making angle 45 degree from positive x-axis, and intercept is negative pi over here. Similarly, another graph will go like this way here, and you can write once again, that is y equal to minus 2 pi plus x, or you can say simply x minus 2 pi also, because it's passing through 2 pi on x-axis, and if you extend this graph, then it will intersect on y-axis at minus 2 pi. Once again, if you draw the graph over here, then the graph is result like this way, y equal to, that is x plus pi, right? And if you draw over here, then once again the graph goes like this way, y equal to that what we call your x plus 2 pi, right? X plus 2 pi for this graph. So this is the graph of tan inverse tan x. Now suppose if I ask you to solve this, the value of tan inverse tan 10, tan inverse tan 10, how to solve this? So let's see how to solve tan inverse, let me write tan 10. How to find tan 10? 10 means it's nearly more than 3 pi. So 2 pi and beyond 3 pi. So let me draw the graph once again, tan inverse tan x. Quickly I will draw like this way, like this way, like this way. This is a rough sketch, nothing else. it is a pi, here 2 pi, somewhere here 3 pi also, right? So here you have to make the holes like this. It's passing through pi, 2 pi, and here let the 3 pi, although it's not the just above, the graph will be there. So here this is 3 pi. So 10 is somewhere here, you see, 10 is somewhere here. So on 10 you have to note down this one. So this line will be y equal to, you say this is x, and it's passing through minus 3 pi, y equal to x minus 3 pi, minus 3 pi. Let me note down over here. Better just let me note down over here. So here let me note down y equal to x minus 3 pi. So 10 will hit on the line y equal to x minus 3 pi. So tan inverse 10, if I note over here, tan inverse tan 10. So what you will write, how you will write over here? So that is simply you just put over 10 over here, x minus 3 pi. So 10 minus 3 pi. 10 minus 3 pi. 10 is exceeded the value of 3 pi, so it is positive. You can see over here, graph is also positive, but it is less than pi by 2 because its range is minus pi by 2 to plus pi by 2. So tan was tan 10 is 10 minus 3 pi. Fine. This is the result of tan was tan 10. This is, say, y-axis. This is what you call x-axis. Anyhow, come to the point. So let's see. This is the tan was tan x we have to discuss. Sometimes it can be asked tan was negative values. Let's see for some negative values how to tackle this as negative values. Let's take a simple question. So if we are interested to find tan inverse, let me take any question here to understand about negative value. Suppose if I ask you to find the value of tan inverse tan of minus 7. Now how to find tan inverse tan of minus 7? So let's say, as you know, tan inverse tan of negative theta, tan minus theta is minus tan theta, and tan inverse minus x is equal to also minus tan inverse x. So simply you will get tan inverse minus tan 7 later on, and this negative sign comes once again minus of tan inverse tan 7. So whatever you find tan inverse tan 7, that is the result of tan inverse tan 7. So let's see what the graph of tan inverse tan 7 says. So this is the graph. Suppose here pi, 2 pi, 3 pi. This part is pi. This is 2 pi. This is 3 pi. 2 pi, that is 6 point something. So 7 will be somewhere between 2 pi and 3 pi. Now you have to notice that this position will be here 5 pi by 2. At 5 pi by 2 there is a hole here. 5 pi by 2 means 1.57. So 5 into 1.57, nearly more than 7. So you know that is 7 will be somewhere here. You just mark this point. 7 is somehow here you can say. So 7 will strike on this line. So as it will strike on this line, so this line become, this is pi by 2 point. This is 2 pi. So this line will be written as y is equal to 2 pi minus x. That is minus 2 pi. No, so minus x minus 2 pi. Y equal to x minus 2 pi. This line can be written as. So negative sign is over here, and for this 7, what do we write here? 7 minus 2 pi. So on multiplying negative sign, that is 2 pi minus 7. The result will be 2 pi minus 7. This can be also evaluated by directly for jump to minus 7. Let's see how. Suppose if we are interested to find tan inverse tan of minus 7. So let's we draw the graph of tan inverse tan x, and then we will go directly on minus 7 position. So we have to consider a negative zone. So we will extend more in negative region. Let's see, this is x-axis, and this what we call here, that is y-axis over here. Okay, so fine. So let's see this part, and so graph is like this way, y equal to x line up to pi by 2, and here you say this is pi, so this is minus 3 pi by 2. Here the graph goes like this way. Okay, this is the part here you can say. Okay, let me write properly. So the graph goes like this way. and here once again the graph goes like this way. Okay, this is the point here, that is minus pi, and here minus 2 pi. Now you know this is minus 7. Minus 7 is where? Minus 7 is somewhere, this is minus 6 point something. So minus 7 is over here. Minus 7 is somewhere here. Here there is minus 7. Hope so. So minus 7 will hit on this one. So it gives the negative region. If you draw the line here, this is the line y equal to x, you know. This is the line y equal to x plus pi. This is the line y equal to x plus 2 pi, right? So the result will be x plus 2 pi, means minus 7 instead of x, and plus 2 pi. That is your result. And final result will be, that is your answer will be, that is 2 pi minus 7. That is the same. Here directly you can find either, or you can find from there also. So let's see. So this is the graph of tan inverse tan x, and now same pattern we will go for cot inverse cot x, cosec inverse cosec x, and sec inverse sec x. So let's take one by one. So let's see cosec inverse cosec x. How to find cosec inverse cosec x? The domain of cosec x is, first of all we have to go for domain. So what is the domain over there? According to as per range, we have to go for cosec inverse cosec x. So you know this is the domain will be minus pi by 2 to plus pi by 2. So between 0 to pi by 2 and between 0 to this one minus pi by 2. So that is minus pi by 2 to 0, and then 0 to pi by 2 we will discuss in detail. So you know this is cosec inverse of cosec x. X lies between, as x belongs to minus pi by 2 to 0 and 0 to pi by 2. So this is the result of domain as well. This is this defined on x for cosec x. For cosec x it defines like this, because at 0 cosec is not defined. So minus pi by 2 to plus pi by 2, you know. So this is x, means x doesn't belongs to minus pi by 2 to plus pi 0 and 0 to pi by 2. Beyond minus pi by 2 and plus pi by 2, cosec will be there. So here you know we have to consider, as x lies between 0 to pi by 2, cosec inverse cosec x is equal to x. This is x lies between 0 to pi by 2, cosec inverse cosec x x. And when x lies between such that here that we say pi by 2 to 3 pi by 2, if you solve this, then you will get pi by 2 to 3 pi by 2, means x lies between pi by, then this result will be pi minus x, means if you solve this, then we will get x is less than 3 pi by 2, correct? So we can write over here 3 pi by 2, and here then is greater than that is pi by 2, you know. Yes, so between this is pi minus x. So let's see the graph over here. Cosec inverse cosec x, this is the graph of cosec inverse cosec x, and where this is the condition when x, this is just analogous to sine inverse sine x. If you see this graph is analogous to sine inverse sine x, just only for x shouldn't belongs to any multiples of pi. X shouldn't belongs to any multiple of pi. We have to discard those points wherever x belongs to the multiples of pi. So you see these part at 0, at pi, here you can note on, here you can say 2 pi, here you can say minus pi, minus 2 pi, such these points you find there is a hole. There is a hole over here. This one is hole here. This one is hole over here. Here you can see these are the holes. Fine. So y equal to x is a line as usual in sine inverse sine x. Y equal to pi minus x, and y equal to x minus 2 pi. As usual sine inverse, if you have a knowledge about sine inverse sine x graph properly, then you can go for cosec inverse cosec x. Just only you have to discard the multiples of pi, nothing else. That is a simple case. And similarly for sec inverse, now you see the graph of sec inverse sec x. Sec inverse sec x is also here, that is x. You see here this is x when x lies between 0 to pi by 2 and difference pi, 0 to pi difference pi by 2, means 0 to pi by 2 union pi by 2 to pi, means you have to forget about pi by 2, because at pi by 2 you know cos x is not defined, so cos x vanishes, so sec x is not defined, so we have to ignore the pi by 2 points. And here similarly 2 pi minus x will be also like this. So that what we call here x lies between pi to 2 pi. If you solve this, then you will find x lies between pi to 2 pi. So this is 0 to pi, that is the y equal to x line, and y equal to 2 pi minus x line. This is 2 pi minus. This graph is, if you see the sec inverse sec x, let me zoom in this one, and it is just analogous to cos inverse cos x, This graph is just analogous to cos inverse cos x, So here, wherever cos x vanishes, at those points, sec x is, yes, as sec x is not defined, so sec inverse sec x is also not defined. So we have to ignore those points where sec x is not defined. Let's see, x equal to, these points are x equal to pi by 2. Here this is 3 pi by 2, That means at every pi by 2 points, odd pi by 2, 5 pi by 2, these are the pi by 2, this is minus pi by 2, this minus 3 pi by 2, this minus 5 pi by 2. Okay, so all these odd pi by 2, as cos x is vanishes, so sec x is not defined, hence we can say sec inverse sec x is also not defined. Just this graph is just only cos inverse cos x type. So you have to remember that sine inverse sin x graph is analogous to cosec inverse cosec x, except those points where sin x is not defined, we have to discard those points in the graph of cosec inverse cos x. Despite of cos inverse cos x, only the difference is sec inverse sec x is actually is cos inverse cos x and sec inverse sec x. Both of them are same graph, but just only you have to ignore those points where cos x is not 0, so that sec x is not defined, which are the odd pi by 2s. And in the case of cosec inverse cos x, at every pi multiples, these are not defined. So these points are not defined points. Otherwise, both the graphs are same. Which one? Sin inverse sin x and cosec inverse cos x, and sec inverse sec x and cos inverse cos x. Now the point is that we have to go for cot inverse cot x. Let's see cot inverse cot x. So let's see cot inverse cot x. This is the graph of cot inverse cot x. Cot inverse cot x is also increasing function. Actually, cot x is decreasing and cot inverse x is strictly decreasing. So these function are decreasing of decreasing. So decreasing of decreasing becomes increasing. As decreasing of decreasing. Mind this point. In detail we will discuss in monotonicity chapter. So decreasing, writing wrong here. Let me correct it. So decreasing of decreasing, let me write, decreasing of decreasing becomes increasing, right? Decreasing of which is composite of decreasing. This is a composite form. So decreasing of composite function, decreasing of decreasing, yani cot inverse cot inverse is also decreasing function. If you see the graph of cot inverse x, it is a decreasing, and check the graph of cot x also, that is also decreasing. So decreasing of decreasing becomes increasing, as like two negatives becomes positive. So that we say here y equal to x, this is increasing graph when x lies between 0 to pi. When x lies between 0 to pi, the result is x. When x lies between minus pi to 0, then it's still y equal to x plus pi, and here that is x minus pi. These are the definitions please consider here. Simply y equal to x definition to be notified over here, because the period of cot inverse cot x is, that is pi. So at every pi interval, cot inverse cot x repeats its same behavior, and the value approaches from 0 to pi only. So y equal to x line, this will be y equal to x minus pi, y equal to x minus 2 pi. Let me go in detail. This is the x-axis, let's say, and this what we call y-axis. So cot inverse cot x, as cot x is not defined wherever sin x vanishes. So where sin x vanishes? At every multiples of pi. So at every multiples of pi, we have to make holes. 0, pi, 2 pi, 3 pi, let's say minus pi, this is minus 2 pi, and let's say this is minus 3 pi. So let me note down, minus 2 pi, 0, and this is pi, this is 2 pi, this what you call 3 pi. We will lift the graph like this way, y equal to x, and here, and hence like this. So these are the graph of cot inverse cot x, These are the graph of cot inverse cot x. Suppose if I ask here, if we ask the question is there, what is the value of cot inverse cot, let's say 8. So what is the value of cot inverse cot of 8? So we have to check where the 8 lies. 8 is less than 9, correct? So 3.3 into pi. 3 pi means 9 point something. It is less than 8. And there is 2 pi means 8 lies between 3 pi to 2 pi, you can say. So where the 8 lies? Here 8 lies. Let's see, 8. Let me note down. 8 is somewhere here, right? So 8 goes on this line. So 8 strikes on this line. So this line will result out on this. It's very clear. Then whatever the value of cot inverse cot x you just provide for x, here you will get always the value lies between 0 to pi only. But cot inverse cot of 8, what the result will be? So here you see that 8 lies between 2 pi to 3 pi. So what the result will be, the lines here between 2 pi to 3 pi. As you know, this line is y equal to x. This line passes through pi, y equal to, as you know, its slope is also 1 parallel to this line, y equal to x and minus pi, you say. And here the line is y equal to x minus 2 pi. It passes through y equal to x minus 2 pi. Let me write down here minus 2 pi, right? So 8 you can submit here, the line that we call over here, that is y equal to x minus 2 pi. So the value of x is here 8. So 8 minus 2 pi. 8 minus 2 pi is the result. Okay, fine. So you can see that 2 pi is 6 point something, means it is less than 8. Okay, fine, less than 8. So that is, of course, it is positive. Fine. So it is positive. You can see over here from the graph also, it's positive. Let's take some illustrative concepts over here. So sine inverse of sine 4 by 3, cos inverse cos 5 pi by 4, and tan inverse tan 2 pi by 3 you have to find. If you check sine inverse sine 4 pi by 3 here, this coverage, let's see, sine inverse sine 4 pi by 3, let me note down. So sine inverse sine 4 pi by 3, you check sine 4 pi by 3. Where 4 pi by 3 is? 4 pi by 3 does not lies in principal value of branch. So you know that what we say, sine 4 pi by 3, that is sine inverse sine 4 pi by 3, you can't write simply sine inverse sine x as x. So as you know, 4 pi by 3 can be written as pi plus pi by 3. 4 pi by 3, some student can write pi plus pi by 3. So sine inverse sine pi plus pi by 3, sine 180 plus theta, you see in third quadrant sine is negative. So that is you can say that is sine of pi by 3, sine pi plus pi by 3, that is minus sine pi by 3. You can note down here, it's not minus pi by sine minus pi by 3, you can say sine minus pi by 3 also. So sine of minus sine pi by 3, so sine inverse minus x equal to minus sine inverse x, so simply we say minus sine inverse sine pi by 3. So now sine pi by 3 will be in positive, so directly you can say minus pi by 3, or you can say sine inverse sine minus of pi by 3, directly we can say minus pi by 3. So the result will be minus pi by 3. Similarly, cos inverse cos 5 pi by 4, you see 5 pi by 4 can be written as pi plus pi by 4 over here. Similarly, 5 pi by 4 you can write over here as for this one. 5 pi by 4 you can say pi plus pi by 4. So cos inverse cos pi plus pi by 4, that is minus cos pi by 4. So pi cos inverse minus x, you know, we know that cos inverse, let me note down, minus x equal to, that is, it's not even function, this one odd function, so it is neither odd nor even, so we can say pi minus cos inverse x. So here you can use this formula, pi minus cos inverse cos pi by 4, and hence we can say pi minus pi by 4. So 3 pi by 4 is your answer. Tan inverse tan 2 pi by 3, then we can write pi minus pi by 3, and tan 180 minus theta, in the second quadrant tan is negative, so tan inverse minus tan pi by 3, and hence we can say tan inverse minus x, we know minus tan inverse x, and that is minus pi by 3. That is your answer, minus pi by 3. Let's take a question. You can also do over here. The value of sine of cot inverse cos of tan inverse x is, let's say, a1, and where x is positive, and the value of cos of tan inverse sine of cot inverse is a2, then you have to find the relation between a1 and a2. a1 equal to a2, first option. Second option, a1 not equal to a2. Third option, a1 is equal to 2a2. And fourth option, a1 is equal to minus a2. Let it figure it out. Let you figure it out. And if not, then you can pause the video. If not, then you can go ahead for further video. Let's unpause and then check the result. So let's see over here. After pausing, over. Let's see. The graph is same here. Solution says consider a1. a1, that is what we say here, in the bracket cos of tan inverse x. Let's say tan inverse x be the angle here whose cosine is taken, so that that is sine of as tan inverse x equal to cos inverse under root of 1 plus x square, as we have discussed here earlier in the previous video. You can see, and here you can see over also this one. Let's see, let me check it out. You can see over here this part. I am talking about this part. Tan inverse x equal to cos inverse under root of 1 plus x square. You can go ahead like this way. Here there is the result. You can see this one. In this result, you can see over here as what we have to check. That was tan inverse x in terms of cos inverse. So let's see over here. This table is sufficient to give the result. Third portion, that is tan inverse x in terms of cos inverse under root of 1 minus x square. This we have discussed in the previous lecture, continued portion, second part. So tan inverse x equal to cos inverse 1 upon under root 1 plus x square. This we are using over here, this one, this formula. Okay, so let's see over here that we have to say tan inverse cos inverse 1 upon under root 1 plus x square, or either you can make the table also like this. Very simple it is. I will give the idea over here. You can make that right triangle here as tan inverse x. Tan means altitude upon base. So x, let's say this is x, this is 1, and this will be by Pythagoras theorem, Gauss theorem, you can say also, under root 1 plus x square, right? Under root 1 plus x square. So cos inverse base upon hypotenuse cos theta, that is the same theta. So we can say this theta equal to cos inverse 1 upon under root 1 plus x square. By this you can find. So directly you can use this result, cos of tan inverse x, that is cos of for tan inverse x, we can say cos of cos inverse this under root 1 plus x square. As you know, this one is this one we can say cos of cos inverse x. Suppose cos of cos inverse x, that is simply we can say x under its domain. So we can directly say under root 1 upon under root 1 plus x square. Directly we can say cos of cos inverse. This is for this very, we can say this one under root of 1 plus x square. Let me zoom in. 1 upon under root of 1 plus x square, right? So for cos of tan inverse x, you can see tan inverse x, we can say cos inverse 1 upon under root 1 plus x square. So here we can say cos of cos inverse, that is same. So that will be cot inverse 1 upon under root 1 plus x square, and sine of this. Now once again you assume this as theta, and then solve in terms of sine inverse. So you can see over here how to solve. Let's make the triangle over here. This is cot inverse. So cot inverse is base upon altitude. So we say 1, and this is under root of 1 plus x square. This one is altitude, and you can find the hypotenuse here by how 1 plus x square. So that is under root of 1 plus 1, that is 2 plus, and here that what we call x square. So that we for sine altitude upon hypotenuse. So under root 1 plus x square upon 2 plus x square. So sine inverse of this much we write, and sine of sine inverse x, that is x simply. So under root of 1 plus x square into under root of 2 plus x square, and hence we can say the result will be under root of that is 1 plus x square upon under root of x square plus 2. So this is the final answer. of under root of 1 plus x square, under root of 1 plus x square, this part, and under root of x square plus 2. Similarly, find a2 also as sine of cot inverse x. So by making a triangle, you can find sine of sine inverse 1 upon under root 1 plus x square, that is 1 upon under root 1 plus x square. So cos of tan inverse sine of cot inverse x equal to cos of tan inverse 1 upon under root 1 plus x square, and hence we can find this the same result. And what the final result will be? So the answer will be same, and hence a1 equal to a2 option is correct. Yani both the results are same results. So first option is correct option, A option. Okay, fine. Now take one more question, illustration over here. The simplest form of tan inverse under root of 1 minus cos x upon 1 plus cos x. Here the condition is x lies between minus pi to plus pi. So A option is minus x by 2, B option is x by 2, C option is x, and D option is none of these. Although this is an IT question, and this is more than one correct segment. This is from the segment of more than one correct option. So it may be more than one correct option also. Let's see. Let me check once again the question. The question is tan inverse under root of 1 minus cos x upon 1 plus cos x, and x lies between minus pi to plus pi, means negative part of x is also there and positive part of x is also there. A option is minus x by 2, B x by 2, C x, and D is none of these. So let's see and let us solve this question. As you see here that x is negative as well positive, and it is under root. So first of all we have to use simple trigonometry for this under root of 1 minus cos x and 1 plus cos x, that is, as you know, 1 minus cos x, 1 minus cos x, you see 1 minus cos x, that is called 1 minus cos x, that we say 2 sine square x by 2, very well known identity. And if 1 plus cos x is there, then you can use 2 cos square x by 2. So if it is under root of this much, then what we have to go ahead. So let it make it under root of this much and this much upon. So under root of this much and upon this, and hence we can say like this will become the equality like this, and here the result is like this way. So 2 and 2 related, and finally that is what is the result will be? Now tell sine square x by 2 upon cos square of x by 2 into under root x, under root of this. So under root, you can say this will be under root of, some student can say tan square x by 2. It's correct. Now as it is under root of tan square x by 2, guess what we have to write? Under root of tan square x by 2, usually student write tan x by 2. So I want to ask over here whether this step is correct or wrong. So this step is correct or wrong? Yes, this step is absolutely wrong. How wrong? Because under root of tan square x, you can't write tan x by 2. If you write this, then you will you will make some flaw. What is the flaw? That is under root of x square. We have already learned that under root of x square, mind this point, under root of x square always use mod x. Otherwise you will miss some solution. You will miss some solution. This is very important point. Under root of x square you have to write mod x. Don't forget to write like this way. So this is a wrong result. This is a wrong result. So finally what we have to put? We have to put mod of tan x by 2 over here. And now mod of tan x by 2. So as x lies between minus pi to pi. So here two cases arises when x lies between minus pi to 0. Minus pi to 0. That we say minus pi to 0. That is minus tan x by 2. And here then when x lies between 0 to pi, then what we say? Plus tan x by 2. Mod tan x by 2. Mod will open like this way. And hence we say tan inverse minus of tan x by 2. Then what we recall over here, that is tan inverse minus tan x by 2. That is, if you say over here tan inverse minus tan x, if you put tan inverse on this all, this both of them tan inverse, then what we say, this will become x by 2 here, and this will become later on we say that is minus x by 2, right? This will become minus x by 2, minus x by 2. So from here this minus x by 2 is also correct, and from here this is x by 2 is also correct. So A and B both options are correct. So this is the important point. Let's see the solution. A and B both of them are correct. Here you see A is correct, B is correct, and here under root of 1 minus 1 plus cos x, that is tan inverse x by 2, and here you have to see that mod tan x by 2, and mod tan x by 2 open if minus pi by 2 is 0, then there is minus tan x by 2, and here you know that is minus 0 to pi, then this is plus tan x by 2, you know this is tan x by 2, and hence we can say tan inverse tan x, that is x by 2, and here that is minus x by 2, and here that is x by 2. So in the both the cases, x minus x by 2 and x by 2, x by 2 as x positive and x minus x by 2 when x is negative. This is your answer. So let's take one more illustration here. The simplest form of tan inverse cos x upon 1 plus sin x when x lies between minus pi by 2 to plus pi by 2. This is also the same question, same pattern. Here simple trigonometry you have to perform over here, and then later on solve and then go for these options. First option is pi by 2 minus x, another is pi by 4 minus x, next is pi by 4 minus pi by 2, and here that is none of these. So let's go ahead for the solution directly. Simply if you solve this cos x upon 1 plus sin x, cos x can be written over here, that is half angle formula, cos square x by 2 minus sin x by 2. 1 can be written as sin square theta plus cos square theta, so 1 can be written as sin square x by 2 plus cos square x by 2, and sin x can be written as 2 sin x by 2 and cos x by 2. Now opening over here, then we see the result is cos square x by 2 minus sin square x by 2 can be written as using square difference formula. By using a square difference formula over here, then what we call that is you can say cos x by 2 a plus b, a minus b result you have to note down. So cos x by 2 minus sin x by 2 and cos x by 2 plus sin x by 2. And here in denominator, if you see the denominator portion, then this result is a plus b whole square, a square plus b square plus 2ab. So that is a plus b whole square. And you find that one of them 2 is related. So that is cos x by 2 minus sin x by 2, cos x by 2 plus sin x by 2, that is tan inverse. And if you divide over here in numerator and denominator by cos x by 2 by cos x by 2, then what we find here, that is 1 minus tan x by 2 sin by cos tan, and here that is 1 plus tan x by 2, that is tan inverse tan pi by 4 minus x by 2. And hence we see this is the result will be tan inverse tan theta and pi by 4 minus x by 2. But here you have to notice what the condition was there. The condition was that is x lies between minus pi by 2 to plus pi by 2. And you know that is what we have to find. The result is pi by 4 minus x by 2. So here what we have to check, that pi by 4 minus x by 2, how this comes. So we have to make up the result of pi by 4 minus x by 2. Let's see. So as x lies between pi by 2 to minus pi by 2, you know, and then after what we call over here, that is for minus x by 2. So x by 2 we can say pi by 4, and here that is minus pi by 4, right? So pi by 4 minus x by 2, before this we have to go for minus x by 2, right? Minus x by 2. So that is how to find minus x by 2. Minus x by 2 can be evaluated as less or equal to negative negative positive. This will become plus pi by 4, and this will become this one, that is pi by 4. So it doesn't affect on inequality. But when we add this pi by 4 minus x by 2, so when we add in both sides pi by 4 over here, then add this pi by 4, right? So we have to add here also pi by 4, here also pi by 4, here also pi by 4. So pi by 4 and plus pi by 4, that will be here pi by 2, and here that is minus pi by 4 somewhere here, this one is related, so 0. So this result will become 0 to pi by 4. So as 0 to pi by 4, if you see tan inverse tan x here, 0 to pi by 4, so it means tan inverse tan of x we have to notify. So here what I have done over there, that is the same result. You know, pi by 4 minus x by 2, we can write here pi by 4 minus x by 2. Okay, let me correct this one. So this part is let's see, this is nothing, this is minus x by 2. Let me correct this, minus x by 2. Minus x by 2 lies between minus pi by 4 2. So pi by 4 minus x by 2 lies between 0 to pi by 4. 0 to pi by 2, correct. So 0 to pi by 2, as you know, 0 to pi by 2, tan inverse tan x, if you check the graph of tan inverse tan x, the graph goes like this way. The graph goes like this way. So 0 to pi by 2, 0 to pi by 2, tan inverse tan x graph is this one same. So that is the same result. To tan inverse tan x means pi by 4 minus x by 2. Simply you have to note down. This is your final answer. Pi by 4 minus x by 2. So the final answer is pi by 4 minus x by 2. This is once again some printing mistake is there. So let me note down here. This is x by 2 and this is the correct option, hence we can say. Fine. So pi by 4 minus x by 2 is your answer for this fourth illustration. This you can see here. So let's see, in this way we will conclude this lecture 1, and another lecture we will go for some more properties of inverse trigonometric function. But here I want to take some more questions on these some properties. Let's see. So let's take some more illustration over here and some more questions for practice. So let's we do some more questions on this, on these topics of inverse trigonometric. Okay, so question number 1 I want to solve. I want to give the question number 1 over here. Let me note down question number 1. If you can note down and you can try yourself also, if cos inverse lambda plus cos inverse mu plus cos inverse lambda, mu, and you can take gamma is equal to 3 pi, say, then find the value of, lambda mu plus mu gamma plus gamma lambda. This question. Let's see how to solve this. So for this question, how to tackle, these are the condition given over here, and here you see how to solve. You can pause this video, you can try yourself, you can also figure it out, and if not, then go ahead for this video. As you know, if you see the graph of cos inverse x, or you can check the range of cos inverse x. So you know cos inverse x, it lies between 0 to pi. So the result of cos inverse x is 0 to pi. So the maximum value of cos inverse x is pi and the minimum value is 0. So if you consider this first given identity, here the result is 3 pi. So, and here there are 3 variety of cos inverse. One is cos inverse lambda, another is cos inverse mu, and another is cos inverse gamma. So for each and every, if you give this pi value of optimum level of boundary conditions, if you can say, if you give all the boundaries as pi for this pi, for this also pi, and for this also pi, then you will correct for 3 pi. And right side is 3 pi, so here it should be only pi. But if you see the graph of cos inverse x, then where it attains the pi, so cos inverse, hence we can say finally cos inverse lambda equal to cos inverse mu equal to cos inverse gamma you say. This is equal to these, all of them are equal to pi. Here it should be, here there it should be, here that it should be pi, correct? So it is only condition when lambda equal to mu equal to gamma equal to -1. You can see from graph also of cos inverse x. Okay, so here each values are -1. So you can submit over here for lambda for -1 and for mu -1. So -1 into -1, that is 1. So each and every value you will get 1. Each and every value you will get 1, 1, and hence the answer is 3. So final answer is 3 because -1 into -1, that is 1, and here 1 plus 1 plus 1, that is the 3. So in this way we can see this one. You can see over graph also here cos inverse x. If you see the graph of cos inverse x, where it attains the value pi over here, this is pi by 2, you can say. This attains at -1 and this attains at 1. So cos inverse x is equal to -1. So x equal to cos inverse x equal to pi. So this x is equal to -1. You know, this is x equal to, you say here this is -1. So in each and every lambda, mu and gamma was -1. So what we have to find, we had to find over there lambda mu plus mu gamma plus gamma lambda, you know, and here we say gamma lambda, that is question mark, and that what we have to find, gamma lambda. So this is all are -1, -1, -1. We say -1 into -1, and once again -1 into -1. So if you find this result, then this is 1, and here plus, the answer is 1, and once again this is answer is +1, and hence the answer will be 3. So let's take one more question over here. Similar pattern question I want to take. Here let me take some harder level, lift the level. Take the question, if sigma of I equal to 1 to 2n, you know, 2n cos inverse xi equal to 0, right? Then you have to find the value of, sigma of xi I equal to 1 to 2n, right? This is question mark, how to find. As you know, cos inverse x vanishes where cos inverse x vanishes. So cos inverse x becomes 0 for every value of 1 only. So cos inverse xi is 0 when it is 0, when xi is 1. So xi becomes 1, and hence each and every of them are 0. So each and every xi should be 1. So as you have to find sigma of xi from I equal to 1 to 2n, so you have to submit the value here, 2n, 1 plus 1 plus, right, plus 1 plus 1, and here what we say, every time you have to make plus 1. How much plus 1? That is 1. Here up to 2n times, here you say 2n times. So how many ones are here? On adding, the result will be 2n. So simply the answer will be 2n. Okay. Similarly, take some more questions over here. So let me frame one more question over here. As if sine inverse x plus sine inverse y plus sine inverse z, illustration number, you would say 3. Sine inverse z is equal to 3 pi by 2, say. And then you have to find the value of sigma of that what we call here x to the power, 20 plus y to the power, that what we call here once again 20, correct, under the bracket, and plus that what we call here x to the power that we say 2019 plus y to the power 2019. Okay, and here then what we say into another bracket, that what we call here x to the power, that is 2021 plus y to the power, similarly any power you can say 2021, right? So 2021, let me write, and into another bracket in denominator also, once again x to the power 2021 plus this is 2021 no? And this is 2019, so this is 2021, and here we say okay 3031 you say, and y to the power 3031, whatever the power you can say over here, right? Then solving what we say here, what the result will be, it is simply here, that is if this will give also 1, this will give also 1, this will give also 1, each and every result will give 1. So if you solve this, the answer will be here, this is the answer will become 1 plus 1, whatever the power will be, into another bracket, that is 1 plus 1, and here also 1 plus 1, and here also 1 plus 1. Similarly, this is for x and y, and due to symmetrical cyclic expression, this is once again that is the same, and this is again that is the same. That is the answer is 1 plus 1 plus 1, that is the answer is 3. Similarly, you can do some more question also. So okay, in this way you can do some problem, and from the next topic we will discuss detail about more properties and derivation of these properties. So thank you all of you.